Jai Hind and welcome once again, class 10th. Today's topic is proving irrational numbers. In this topic, I'm going to take root 2 and I'm going to prove that root 2 is irrational. To prove a given number irrational, we use the method of contradiction. So let us assume that root 2 is a rational number. Root 2 is a rational number, and we know rational number I can write in the form of a by b, where b is not equals to 0, and a and b are co-prime, and we know co-prime numbers always have one and only one common factor, namely 1. So the common factor of a and b is 1 only. Okay. Now squaring on both sides, root 2 square equals to a square by b square. So this I can write 2 is equals to a square by b square, or I can write b square is equals to a square by 2, a square by 2. So this equation gives me what? This equation gives me what? A square by 2. When a square by 2 says that a square is divisible by 2, it implies that a is also divisible by 2. Divisible by 2. Okay, so we can say that 2 is a factor of a. 2 is a factor of a. Now let us say that a is equals to 2c. Okay, a is equals to 2c, and our previous equation was what? B square equals to a square by 2. Putting the value of a here, so what will get? B square equals to 2c whole square by 2, that is b square equals to 4c square by 2. B square equals to 4c square by 2, which I can write what? So which I can write b square is equals to c square. B square is equals to 2c square, right? Therefore I can write c square is equals to b square by 2. Now this equation is giving me what? This equation gives me what? It means b square is divisible by 2. It implies that b is also divisible by 2. So 2 is a factor of b also. So I can say that a and b have at least 2 as a common factor. Okay, a and b have at least 2 as a common factor, right? But this contradicts our assumption that a and b are co-prime. In the start I said that a and b are co-prime. If a and b are co-prime, then they will have one and only one common factor, namely 1. But here what we have seen, A and B have at least 2 as a common factor. So this contradicts our assumption that A and B are co-prime. So our assumption is contradicted. Our assumption is contradicted. What was our assumption? That root 2 is rational. It means root 2 is irrational. It means root 2 is irrational. So hence we proved that root 2 is irrational. So this is how we have to prove a given number irrational. Now I am going to discuss uh, I'm going to discuss a question. See, let us say that the question is, prove that 3 plus root 2 is irrational. So how to prove? See, 3 is rational, 3 is rational number and root 2 is irrational number, right? So what we will do, first of all we will prove this root 2 is irrational. And how we will prove? As we have discussed, right now we have discussed how to prove irrational number. So by that method we will prove that root 2 is irrational, and then we will do like this: 3 is rational, rational plus irrational, that is always irrational. We have read this property. One more thing, let us say our question is 2 plus 3 root 5. Prove that 2 plus 3 root 5 is irrational. What we will do? We will take root 5. We will prove it irrational, right? Now 3 is rational. Rational multiply irrational is always irrational. We know that. This plus sign and this 2 is rational. And rational plus irrational is always irrational. So this is how we have to deal with these types of problems. Okay?